Hello, good morning, everyone. So my name is Chetan. So I have completed my post-graduation MTech in Digital Electronics and Communication from Manipal Institute of Technology. So I have more than 6 years of experience in training field. So I will be handling your CCNP advanced batch. So let me have a quick introduction about yourself, and then we'll move on to discuss about the topics. Yes, we'll start with Vaishnav. Tottathil. Yes. Yes, Vaishnav. Are you there? Okay, Ankur.
Hello everyone, I'm Ankur Ismano. Currently I'm working in Capgemini as a NOC engineer. So yeah, that's it.
Okay, thanks. Vaishnav.
Hello,
Hello, tell me.
can you hear me, sir?
Yes.
Yeah, I am Vaishnav. I am from Kerala. Now I am currently working on TCS. And I took a 2-month gap. Now I am joining this group.
Okay, thanks, Vaishnav. BB.
Thanks, Ketan. My name is Bibi. Actually, I'm currently working as a NOC engineer with Wells Fargo Bank.
Okay, thanks. Ganesh.
Hello, sir. I'm from Chennai. Right now, I have pursued CCNP course, and right now, I'm special.
Kita.
Good morning, sir. I'm Harshita. I have completed my engineering in electronics and communication. I don't have any work experience.
Okay, thanks. Mohammed.
Good morning. My name is Ashik, and I'm a freelance web developer.
Selva Kumar.
Hello all. Myself, I am Selva. I'm working in DC network engineering in Extra Delta.
Okay, thanks. Tarun.
Hello, sir.
Hello.
Myself, Tarun Patel from MP Indore, and right now I am working in Reliance Jio. I have a 10-year experience, and I am enrolled for CCI security.
Okay, thanks. Yes.
I'm from Mysore. I completed BCom.
BCom. Okay. Yes.
My name is Tushar. I am from Punjab. I completed my BTech in CSC last year, and I will go for CCI.
See?
BC. My name is Savana. I'm from Delhi. Completed BC.
Yes.
My name is Suhas. I completed my BCA.
That's good. They're unable to hear you. Be loud. Yeah. Monday. CCI security. Okay, guys. So let's discuss about the topics. So what all we'll be covering in advance. So in advance, we'll be starting with GRE. I hope anybody has any idea about GRE. Okay, no problem. GRE stands for Generic Routing Encapsulation. So we'll talk about GRE turn, and we have a lab to do as well. Then we have site-to-site VPN. So we'll implement IPsec over it just to provide the security. Then we have Dmvpn. So in Dmvpn, we have 3 phases. So we have phase 1, we have phase 2, and phase 3. So we'll be discussing with the protocols like Eigrp, OSPF, and BGP. So you need to be good with these 3 protocols. So moving on, we discuss about the VRF, that is virtual routing and forwarding. We'll see how to create this VRF. We have 2 types of VRF, VRF Lite and VRF Major. So we'll discuss about both the things. Then we have MPLS. So then MPLS layer 3 VPN and VRF Lite as well. So we have VRF and we have VRF Lite. Then we'll do a task. So I'll not be following this. So I'll start with GRE, that is VPN. Then we'll finish off MPLS. Then we'll move on to multicasting. So first topic we'll be finishing is VPN. Then we'll go on to the MPLS. Then we'll finish with MPLS and VPN. Then multicasting. So in multicasting, we'll be discussing about IGMP protocol, PIM, and we have a lab to do as well. So in PIM, we'll be discussing dense mode and sparse mode as well. So these are the major topics we'll be discussing. Then we have IPv6 as well. So if we talk about IPv6, we'll see how to enable RIP-NG, your OSPF version 3, and redistribution as well, and the BGP part. So, and we have these extra topics of console security, VTY security, password encryption. We have TFTP, trivial file transfer protocol. Anybody knows about the TFTP? Okay. And then we'll discuss about HTTP and HTTPS. What is HTTP port number? 80. Which protocol it uses? TCP. What about HTTPS? 443. Which protocol it uses?
Sir, application.
Application layer. Okay. Then we'll move on to SCP, session control protocol. Then we have AAA, reverse path forwarding, and control plane policing. Then we have these two topics, Lisp and VXLAN. So these are the topics we'll be covering in the advanced part. Yes. VXLAN. So now, so today we'll not be starting with any advanced topics. So let's quickly brush up with the routing part. I hope everybody is good with routing. Done with routing, right? So okay, let's start with Eigrp.
Hi Chetan, BB here.
Tell me.
Hey Chetan, just have a doubt. Like just now you showed, right?
Mm-hmm.
Is that the entire syllabus for our CCNP advanced or
Yes.
only for the routing part?
No, this is advanced part. CCNP advanced.
Okay. Okay. I just have a concern because actually I'm applying for CCI Enterprises too.
Mm-hmm.
So in this CCNP Enterprises, we don't cover the SD-WAN and SD access part.
So that is separately covered.
Oh,
SD-WAN and
okay.
SL6 by Vikas.
Oh, okay. 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 It's a separate part, right?
Yes. Yes. Yes.
Okay. Cool. Yeah. Thanks.
Okay. All right.
Good luck.
So what does Eigrp stands for?
It's enhanced Eigrp.
Okay. So why we call enhanced? Yes. We can call Eigrp also, right? Why we call it enhanced?
Okay. What I heard is actually I haven't used any kind of Eigrps. Like Cisco Eigrp has more features and compared to Eigrp. That's what I heard. I'm not too sure.
Mm-hmm. So why we call enhanced is there was another protocol called Eigrp. This was the old protocol. This is interior gateway routing protocol. So if we talk about the major differences between Eigrp and Eigrpr, this was classful. There was no authentication support in Eigrp and there was no manual summarization as well. So that's why they moved on to Eigrp, because Eigrp supported only were classful subnets like /8, /16 and /24. So if we talk about Eigrp supports both your classless as well as classful. And in Eigrp, no authentication support. And you can't do manual summarization. So no manual summarization. So what do you mean by summarization? Combining into network. Summarizing the address. What do you mean by that? Asking that.
If we have multiple classless subnet, we can summarize into a single subnet.
So basically what do you mean by summarization? Shortening your routing table size. So instead of sending 4 routes, we'll be sending only one summary route. So now, so let's talk about Eigrp. Which layer Eigrp works? Which layer of OSI? Layer 3, network layer. So what is the protocol number? Does it have a protocol number or a port number? Good. Protocol number. What is the protocol number of Eigrp?
Eighty.
80? Is it 80 or 88 or 89? You have 3 options.
88.
88. So protocol number of Eigrp is 88. What is the multicast address it uses? 254. 224.
0,
0,
9,
0,
9,
9.
9, 10, 10,
9 is wrong.
10.
10. After 9, 10. Okay. This is for RIP.
Yeah, question 2, right?
RIP. This is for Eigrp. 224, 0, 0, 10. What about OSPF? Good. What are those?
It's 5 and 6.
Okay. What about BGP? So what is 224.0.0.5? What is 224.0.0.6? Why do you use 2 multicast addresses? Very good. Which one is for DR? Good. 6 for DR, BDR? Not DR others. It is for all OSPF routers. So now, so Eigrp has multiple packets. What are the packet types of Eigrp? How many packets are there? 4, 5. Yes, how many? Choose one, 4 or 5.
It's 5.
5, okay. 5 or 4? 5, okay.
You mean the hello update or all those packets, right?
So we have 5. So we have hello. We have update. We have query. So we have reply. And we have acknowledgement. So what this hello packet is used for? Good. For establishing neighborship and maintaining as well. Not only establishing. So what is the by default hello type? No. Yes. What is the by default hello and hold type?
5 and 15.
5 and 15. Good. So by default, hello is 5 seconds and hold is 15 seconds. Now, why we use update packet?
If there is any kind of new addition of routes.
Only new addition of routes. Change in topology to exchange your routing information. What about query packet?
If some vector route will be not there,
Mhm.
then router generate a query packet for another neighborship.
If you have feasible successor in a topology table, will the router query? Suppose we have successor, right? We have successor and feasible successor in EHR. So let's consider my successor is down. So we have a feasible successor in our topology table. Will the router query or not? Why it will query? It has already a backup path installed in the topology table, right? So whenever you don't have a successor and a feasible successor, then only your router will start querying. Otherwise, it will switch to the backup path, right? Which is present in your topology table. So reply is sent. Reply for a query. And finally, acknowledgement just for reliability. So which are the reliable packets? Yes, tell me. Yes. So which are the reliable packets?
It's query and reply.
Only query and reply are the reliable. What about hello? Is hello a reliable packet? What do you mean by reliable packet first of all?
Well, if you send a packet and there will be a reply for that,
you'll get an acknowledgement back, right? So which
Yeah.
are the packets? You get an acknowledgement back. Very good. We have three reliable packets. That is update, query, and reply. These are the three reliable packets.
Chandan, just a doubt actually.
Just tell me.
Okay, and just now you said that the query packet, right?
Yes.
Let's say if we have a feasible successor and a successor,
Mhm.
and if the successor goes down, the query will generate.
Yes.
Let's say if a destination route is down,
Mhm.
in that case, query will generate.
It depends on the feasible successor, right? So what do you mean by feasible successor first of all?
The best path.
It's a loop free, best path, second best path to reach to the destination. Correct, right?
Yeah.
So when you have a feasible successor in your topology table, that will not be by default installed in your routing table because only the best path, that is your successor.
Yeah, right.
But what about feasible successor? It will be present in your topology table only.
Topology table.
So once your successor goes down, then your feasible successor will come to your routing table. Then
Okay.
why you need to query at that point of time? You already have a backup path, right? So why we need to query it for that reason. So when we don't have a successor and feasible successor, then only a query will take place.
Okay, I got your point.
Yes.
But what I am asking is, let's say I have three routers, R1, R2, and R3.
Mm-hmm.
Okay, and in R3 I do have a
Loopback?
interface, loopback 3.3.3.3.
No. Yes.
Okay, I have a direct path from R1 to R3 too.
Mm-hmm.
Let's say if this 3.3.3.3 goes down,
Mm-hmm. It will start querying because I don't have a backup path here, right?
yeah, here there is no backup path. I mean, if a direct connection from R1 to R3 also there, let's say if 3.3.3.3 goes down, R1 will generate a query or R3 will generate a query?
R3 will generate a query. Is loopback, right?
Yeah.
So first, who will come to know? R1 will come to know or R3 will come to know? R3 will come to know, right?
R3 will
he has
come to
his loopback is going down.
Right.
Not R1, right?
Right.
Yeah. All right. Now.
Okay. Okay.
Moving on.
Sure.
So what were the topics people discussed after this? Packet types, then?
Yeah, packet types, reliable and non-reliable packet types.
Okay, what about after that?
Till there we stop.
Stopped. Done with that. Okay, no problem. So what are the neighborship criteria? Okay, we talk about neighborship. So let us consider we have two routers. We have R1 and we have R2. So every 5 seconds, hello is generated. Why we generate a hello packet every 5 seconds? Just to say this router is alive. So every 5 seconds. R1 should say, I'm alive. R2 should also send a hello packet every 5 seconds. Otherwise, it will wait for the hold on time, that is 15 seconds, and then declare the neighbor as dead. Clear? Now, tell me what are the neighborship criteria. Do we have neighborship criteria?
Yes.
Yes. What are those?
Yes, number should be
Very good. Then
and same network.
same network, same subnet, common subnet. Please note it down. You don't know. ASN must match. Common subnet.
Even
Very good. Key values must match. Then authentication must match if configured. Then any other? ASN is done. Common subnet, key values, authentication. Yes, online guys. What about timers? Timers need to match near Eigrp. Need to match. Why? No need to match in Eigrp. So why we tell in OSPF no timers must match, because we have network types. How many network types? Network types in OSPF 5. What are those? We have BMA, broadcast multi-access. We have NBMA, non-broadcast multi-access, point-to-point, point-to-multi-point broadcast, and point-to-multi-point non-broadcast. That's why we say in OSPF timers must match, because every network type has different hello and hold on time. Clear? So in Eigrp, timers no need to match. Let us consider on R1, I went and configured hello as 5 and hold as 15. So I went to R2, configured hello as 3 seconds and hold as, let us consider 9 seconds. So they will negotiate to the lower values. Clear? So now what about router ID? Router ID should be unique, or if it is same also it is okay. Not compulsory, right? So router ID, if it is same, yes. Let us consider I configured on R1 1.1.1.1. When I went to R2, configure the Eigrp router ID as 1.1.1.1. Will they have the adjacency? No. They will have adjacency. But the problem with the same router ID is they will not exchange any routing information. They will form the adjacency. The adjacency doesn't have any problem, but the problem is they will not exchange the routes. Yes. Please make a note. If the router ID is same in Eigrp, neighborship will form, but they will not exchange the routes. No, no. So now we'll discuss about, I hope everybody knows this. We have a successor. We have a feasible successor. We have reported distance. Or we also call it as advertised distance. And we have feasible distance. Now, what do you mean by successor? Best path, loop free, best path to reach to your destination. What about feasible successor? Very good. Again, it is loop free, second best path to reach to your destination. What about reported distance? It's the neighbor's distance to the destination. What about feasible distance? Total distance from source to your
Source to destination.
Yes, right. Now, so if we talk about feasible distance, what is the formula? Anybody remembers the formula of feasible distance?
A reported distance should be less than.
That you are talking about feasibility condition.
Yeah.
Yes.
Cost plus.
Cost plus. This is the formula. 256 into K1 into 10 to the power of 7 divided by minimum bandwidth plus K2 into 10 to the power of 7 divided by minimum bandwidth divided by 256 minus load plus K3 into sigma delay, we call it as total delay divided by 10 multiplied by K5 by K4 plus reliability. So this is the formula what Eigrp uses to calculate the best path, that is feasible distance. Seen this formula? Not understanding anything? Able to see? This is total delay. So now, if we talk about K values, we have K1, we have K2, K3, K4, and we have K5. So what K1 stands for, what K2 stands for, K3, K4, and K5. Very good. Then reliability direct. K2 is reliability, no. Load. Next, delay. Here comes your reliability, K4. And K5 is empty. So in this 5K values, we only use 2 K values. Which are those? Delay. Why? Yeah, that I know. K1 is equal to K3 is equal to 1. And K2 is equal to K4 is equal to K5 is always kept 0. My question is why only K1 and K3? Before that, this formula reduces to 256 into 10 to the power of 7 divided by minimum bandwidth plus sigma delay by L. So after implementing these K values,
So when we redistribute this Eigrp into another protocol,
Mhm.
then we should have a matrix.
yes,
That is better than where
using you'll always use 1 1 1 1, right?
Yes.
Everywhere. Just for consideration. Otherwise, you need to go show interface name. If you want exact answer, so you need to go to that particular interface, find the bandwidth, delay, reliability, load, MTU, then you need to substitute it. So even in the exam, CCI exam as well, you'll just use 1 1 1. You want proper redistribution, then you need to find the bandwidth. Yes.
then we can calculate the matrix.
Yes. Any doubts? Tell me, why K1 and K3 are 1? Why these are kept as 0?
Because Eigrp is fastest.
Fastest.
One is for faster traffic will be goes.
But we can use reliability also, right?
And we can say that the only bandwidth and there is
Delay. Yeah, that I got that. I got that point. So you are telling like we use bandwidth and delay into consideration in order to calculate the best part. But my question is, why not K2, K4, and K4? They're also good, right? Looks good only. It's load looks good. Reliability looks good. MTU also. So why we kept them as 0? Even Cisco recommends not to use these values. You always use only K1 and K3. Why? Yes. No. What about online, guys? I hope you got my question.
So what will be change?
Very good. If you talk about K1 and K3, these are static values. What do you mean by static? They don't change over a period of time. These are static values. Whereas if you talk about your reliability, MTU and load are dynamic values. They change over a period of time. Studied nicely. Good. Static values and these are dynamic values. What do you mean static? Fixed over a period of time. One more small question for your interviews. Why we multiply by 256? Can I multiply by 65534 or any other number? Little bit history. Yes. Tell me. I'm unable to hear you properly. Please put it in the chat box. So why only 256? It can be any other number, right? You can use 300, 350. Why only 256? Because I told you about the old protocol. It was Igrp, right? It was a 24-bit metric. 24-bit. If you talk about Eigrp is a 32-bit. What is the difference between 32 minus 24? It is 8. 2 to the power of 8 is 256. Maximum value of half count. You're talking about the half count. Clear? So why 256? If anybody asks you why 256, because the older protocol called Igrp used 24-bit metric, whereas your Eigrp uses 32-bit metric. Yes. 32-bit metric. That's why what is the difference? It is 8. So 2 to the power of 8, 256. That's why. Just for your knowledge, nobody will ask you about it. Done? So now, I hope you guys have heard about equal cost load balance and unequal cost, right? So let us consider this topology. We have R1. And we have a loop back. So what by default Eigrp does? Equal cost load balancing. If it's 100 packets, so it is equally divided into, it will go through R1, R2, R3, R1, R4, R3, and R1, R5, R3. Now, what do you mean by unequal cost load balancing? Any idea?
So it calculates the first matrix.
Mm-hmm.
And if R5 is the pass estimate,
Mm-hmm.
and R4 is
Did in GNS3 lab? Because EVNG supports only gigabit, right? No, where you practice this lab? EVNG, but in EVNG only gigabit, right? How you did that? Good. You told like one will use gigabit F0 bar 0, E0 bar 0. That is fine. Anyway. But in EVNG it supports only gigabit, right? Then change the delay or something. Change the delay. Went to the interface and change the delay. So now what do you mean by unequal cost load balancing is? So only successor is present in your routing table. So in order to bring your feasible successor from the topology table into the routing table, we call it as unequal cost load balancing. How you do that? With the help of variance. So router Eigrp, ASN, and you'll configure variance there. Variance and the number. So what is the variance formula? How it calculates variance? It is feasible distance of feasible successor divided by feasible distance of successor. Correct? So if the value comes up to 1.2, please round it off to the next digit. That is to go under router Eigrp process or ASN and configure variance and the number. Variance if it is 2, is configured. So why unequal cost load balancing? In order to bring your feasible successor from the topology table into the routing table. By default, only successor is present in your routing table. Please mute your mics. Thanks. Now, so I hope everybody knows about summarization, shortening the routes of your routing table. One small question I have in summarization. So let us consider we have R1, R2, R3, R4. So we have loopbacks. So loopbacks here, 172, 172.16.0.0/24. We have 172.16.1.0/24. We have 172.16.2.0/24. And we have one more loopback, 16.3.0/2. So I'm going to R1 and manually summarizing. What is the summary address of this? Wait, yes. Subnetting. Subnetting only. Okay, before this. 0.0, you are doing what is a it's not manual summarization, it is auto summarization you are doing. Okay, no problem. So before that, please calculate for this. Yes. 1 dot. You want to go back to that topology? Yes. What do you mean by summarization? Reduce, right? It should be reduced. You know how to reduce this?
Should be 23, right?
/22. Good. So before that, one subnetting question for this. So I hope everybody knows about class C. So calculate network ID, broadcast ID, and valid range. Very important. If you're attending for interviews, every interview will get a question on this. That is. Please mute your mics. So take this IP 192.168.200.200/28. Yes. Online guys, please put it in the chat box directly to me. Valid range or valid host. Everybody knows subnetting, right? Good. What about broadcast ID and usable range? Good, Mohammed. Wrong, Ganesh. Please check. Talking about the host networks. I'm talking about the network ID. Yes. Physical. Valid range. Good. Yes, guys. Only one out of 17. 16. Okay. So what about network ID? What is the network ID? 128. No.
192 is the network ID.
Very good. Then?
192 16 hosts. Total 16 hosts will be there.
Okay. 16 is your block size. Then?
Yeah, block size. Then we can use 14. After
what is the broadcast ID?
It's 207.
Very good. Valid range is from 193 to
193 to 206.
Yes. Everybody got the same answer? Who all got? What? Did? No. How? How you calculated?
So, we take that to 28 binary.
Okay. But in interview, only 1 minute. You need to be. So only 1 minute. Then we'll go to next question. So binary is little bit, what do you say, hectic to calculate at all. Anybody knows better answer? How to calculate? Yes, online guys. How? Yes, Mohammed. How you calculate it? Let me know the procedure.
I just
Yes.
checked out the prefix link first.
Okay, very good. Then
for network ID. Then for broadcast ID, I made the host bits as 1 and added that to the network.
Okay. So what about BB? BB has also calculated. No?
Yeah, actually, what I use is like you have the block size, right? For 24, it's 256. For 25, it's 128. 20. The next one is 64, 32. Yeah, I'm using that way of.
So very easy, guys. See, just remember this number. I hope everybody remembers this number. 256. Now write the subnet mask. What is the subnet mask? Yes. What is subnet mask?
It's 255, 255. 240.
What is 256 minus 240? This is your block size. Just start dividing by 16. 0, 16, 32, 48. It goes up to 160. 160 plus 16 is 176 plus 16. 192 plus 16. Where your 200 is lying. This is your network. So just minus 1 is your broadcast. What is the valid range? 193 to 206. Real quick. Because in interview, you get only 1 minute. Clear? One more? Okay. Start. We'll take class with this time. So we have 172, 16.150.150/21. Yes. Need to find network ID. Need answer from everyone. Network ID, broadcast, and valid host. Please don't hesitate to ask the question. If you guys don't know, let me know.
only minus that number 256 on the subject number. We should multiply that.
Start dividing. Very good. Good. I got answer only from 2. What about others? Good. Good, Tarun. Don't use subnet calculator. You get the answer very fast.
144.
Very good. Then, what is the broadcast? Very top. Good. 150, 144 to 151 is the range. What is the network ID? Complete network ID?
172.16.144.0.
0. What about broadcast?
172.16.151.
255. What is the valid range? Taking this much time? Why? 256. What is the subnet mask?
248.
Very good. What is 256 minus 248?
8.
So 8 is your block size. Start dividing by 8. So 88 plus 8 is how much? 96 plus 8 plus 8 plus 8 plus 8, then 144 to. You need to know which bit is changing. So what is your network? 172.16.144.0. What is your broadcast? 172.16 minus 1. 151.255. What is the valid range? It is from 172.16.144.1 till 172.16.151.254.
254.
This is your valid range. This is your network ID. This is your broadcast. This is valid. %? Sure. Good. Done? Okay. Now let's come back to summarization. So let us consider we have 4 routers. So on R1, I went and enabled manual summary. There is 172.16.0.0/22. So these are my loopbacks. 172.16.0.0/24. I have 172.16.1.0/24. I have 172.16.2.0/24. And I have one more loopback 3.0/24. So what will be the summary? It will be 22. So now my question is, so R1 will advertise it to R2. So R2 will to R3, R3 to R4. Now how R1 will avoid the loops? There is a loop, right? How?
We have to use a split horizon mechanism, right, in Eigrp to avoid the loop.
I'm talking about summarization. Yeah, that you're talking about split horizon. That is using hub and spoke. So what about this R1? How R1 will avoid the loops? When we do summarization on R1, that is manual summary. Have you heard of null zero? Null zero? No. So as soon as you do summarization on R1, it will create a null zero route. What is the metric value of null zero? It is 5. So once the R1 advertises this network to R2, so R2 to R3, R3 to R4, then R4, when advertise it to R1, R1 will never accept this route because of null zero. Please do this lab today when you go to home. It will create a null zero. No? So now final authentication. What are the authentication supported in Eigrp? MD5. Then one authentication. We have HDLC. That is a protocol in layer 2. So we have HMAC, SHA. So this MD5 is supported in your normal mode, that is classic mode. This is supported in your name mode. Okay, so this is about Eigrp. So please revise once again once you reach home. So now we'll talk about OSP just for half an hour. Yes, tell me why OSP? Which layer OSPF works? Network. So multicast address, you know, 0.0.5, 0.0.6. Which algorithm it uses to calculate the best path? Dijkstra's. But Dij KSH TRA algorithm. How it calculates the best path? What is the metric? Yes, very good. Cost. What is the formula for cost? Very good. Super. Reference bandwidth divided by interface bandwidth. What is the reference bandwidth? 100? No. So interface bandwidth depends on your interface, whether you are using a gigabit or a fast Ethernet or Ethernet interface. Clear? Now, so I hope everybody heard about this. DR, BDR. Now tell me, what do you mean by DR and what do you mean by BDR? So why we need DR, BDR first of all?
In order to restrict multiple routes shared by the routers, one consolidated route will be shared by the DR to the route. So that routing.
So where we use this? Where we use this concept of DR, BDR?
Inside the area.
Inside area or on a multi-axis segment?
It's a multi-axis segment.
Very good. So if we talk about a switch, let us consider a switch. So we have R1, we have R2, R3, R4, we have R5, we have R6. So how many adjacencies? 6. Full mesh, full mesh. How many full mesh adjacencies? How you calculate? Using the formula n into n minus 1 by 2. So 6 into 5 by 2. How many adjacencies? 15 adjacencies. So with 6 routers, we are forming 15 adjacencies. What about with 10 routers? We'll be forming 45 adjacencies. So as the router goes on increasing, the OSP of adjacencies will goes on increasing. So in a multi-axis segment, we use the concept of DR, BDR. So one router will become the DR. So what do you mean by DR? Designated router. What do you mean by BDR? Backup designated router. So if DR goes down, then BDR will become the DR. So what is the election criteria? How it elects a DR? Router ID, direct router ID. Before that, something it will check. What?
Highest priority.
Very good. So if you talk about the election criteria, so what is the by default priority of OSPF? Yes.
8276.
No, that is STP you're talking about.
Yeah, right.
100 or 1. Priority is 1. So first, it will check the priority of each and every router. So if priority is same, then highest router ID. Now tell me. So let us consider R6. I have configured the router ID as 6.6.6.6. On R5, I configured 50.50.50.50. On R4, went and configured 7.7.7.7. On R3, it is 3.3.3.3. R2, 2.2.2.2. And R1, 1.1.1. Who will become the DR? Where? R5? No. So what is the by default hello and hold on time? 5 and 40. That is for Eigrp. 5 and 50.
30 and 90, right?
How much?
10, 30 and 90, right? In BMA.
10 and 40. BMA?
10 and 40, okay.
So for NBMA, it is 30 and 120. So first, the election will happen. So highest, since the priority is the same on all the routers, highest router ID will become the DR. Who will be the BDR? Clear? Any doubts? So why we use DR BDR? Just to reduce the flooding of LSAs. LSA stands for? What does LSA contains? Good. Database. Every OSPF related information is present in your LSA. Clear? Now. So what are the message types in OSPF? How many we have? Notes?
The 8 types.
8 types. Oh, wow. Tell me 8 types.
Is that the one? I'm not sure.
No. It's not 8 types. It's 5 types. We're talking about neighbor states.
Oh, okay.
This is. What are those? Hello? Then? Correct. Correct. DBD. What do you mean by DBD?
Database description.
Database description. Good. Then LSR. Then
LSU.
Then
LSR.
So if we talk about again reliable packets, we have 3 reliable packets: DBD, LSR, and LSA. So why we use hello packet? Again, to form the adjacency and maintain the adjacency. So what about DBD? Again, used to exchange the routing information. That will be the summary of your LSDP, link state database. What about LSR? Any changes? Then it will send an LSR. LSU is in reply for an LSR. LSAC, just for reliability. So for a DBD, LSR and LSU, you will get an LS acknowledgement. Just for reliability purpose. Clear? Now, What about neighbor states? How many neighbor states we have? 8. What are those? That initial.
Down,
Okay.
down,
Then
attempt,
init,
two-way,
two-way,
extract, exchange, route.
so only 7, right? Where is one more?
Attempt.
Attempt. So we don't normally get this attempt state because it is used for NBMA. So in frame relay and all, normally we use this state, attempt state. So now, can anybody tell me in which step your DR-BDR election happens? In which state DR-BDR is elected?
Is it two-way or extract?
It's two-way. DR-BDR election. In extract, master and slave election. So why tell us a master and a slave?
It's like who will be initiating?
Who will
a
initiate
DB?
your routing information exchange? Always highest router ID will start exchanging. Let us consider we have 2 routers. So let us consider the IP 192.168.12.0/24. This is .1. This is .2. So what is the router ID of R2?
$12.2.
12.2. So how router ID is elected first of all? What is the election criteria for router ID?
Highest priority.
Priority? No.
Router
First
ID.
is manually configured. So if it is not manually configured, then highest interface loopback.
Loopback.
Yes. Yes. Loopback IP. So even if your loopback is not configured, then it will check highest interface.
Interface IP.
Yes. So what happens in exchange state? DBD. DBD is exchange in exchange state. So what about loading? Your LSR and LSU, then you go into the full state. So we have DR-BDR, right? Tell me what will be the state between DR and BDR? What will be the OSP of neighbor state? DR and BDR? DR and DR other? BDR and DR other? And DR other and DR other. Yes, what will be the neighbor state? Full state, very good. So what about DR and DR other? Very good. What about BDR and DR other? So what about DR other and DR other? Very good. So it's in two-way. Please remember, very important for interviews, two-way state. Done. Now, one more question I have. A small question I have in my mind. So we have R1. So okay. So sorry. So we have a switch. We have a layer to switch. We have R1, R2, R3. I have 4 routers. So what is the by default priority? 1. So now I don't want this router to participate in the DRBDR election. How to do that? So normally they will participate. Normally each and every router participates in the DRBDR election. Now my question is, I want to disable this router from participating in DRBDR election. How to do that?
Making priority 0.
Very good. By making the priority as 0. Please make a note. So if you make your priority as 0, then that particular router will never participate in DRBDR election. Yeah.
Hey, Chetan, I'm sorry to ask. Hello.
Tell me.
Okay. When we say about the OSPF router ID, right? We said the first criteria is we can configure a router ID manually.
Correct. Go to the OSPF places and configure the router.
What will be that value? I mean, is it a
Any value you can take? So it depends on
a
your task, right? So let us consider I want to configure R1 as 1.1.1.1. So go to router, OSPF, PID, that is your process ID, then assign the router ID.
Yeah, that means the router ID should be a 4-octet.
Yes, 32-bit. Yes.
Like if I need a router ID is 10, I can't give that, right?
Which one? 10, no, it should be 32-bit.
Okay, it will be 32-bit only, right? Like either a manual or, I mean, either a virtual or physical IP address.
Yes. If you are not configured manually, then it will check the hash interface loopback. And even if loopback is
automatically
configured, it will take the interface.
Yeah. Okay. Yeah, cool, man. Thanks.
Now, talking about neighborship criteria. So what are the neighborship criteria in OSP? Same area ID. Then
authentication.
Okay.
Area type should be same.
Very good.
Then
area type.
Hold on, the timer should match.
Must match.
Subnet should be same.
So common subnet.
A router ID should be same.
Should not be same. Should not be same.
Unique. Router ID should be unique.
Unique. Yeah.
Yeah, should not be same.
Yes. Then any other? Then passive interface should not be anything. I hope everybody has an idea of a passive interface. What do you mean passive interface?
If we don't want to send any OSPF update to an interface, particular interface, we can make it as.
So even in Eigrp, we have physical interface, right?
Yeah.
So you want make a note in Eigrp neighborship criteria, passive interface should not be enabled. So if you enable passive interface under a particular interface, it will just disable sending of your hello packets. And even network types must match.
This empty is actually an exception, right?
If it doesn't match on a particular router, they'll be stuck in init step. So just try this, okay? Today, please go on. By default, it is 1500, right? MTU. So just change this MTU, even this must match.
Okay.
No? Okay, moving on. So we have area types. How many area types we have?
Area 0.
How many? Lot of 0, 11. No, that is LSA types you are talking. So we have
4, right?
5. You have normal area. This is your backbone. So we have stub. We have totally stub. Very good. We have NSSA and totally NSSA. So before discussing about these network types, sorry, area types, we'll discuss about LSA types as well. How many LSA types we have? 11? 7. So we have LSA type 1. So what we call this LSA type 1 as? Router LSA. So you need to know two things about LSAs. Who is the originator? Who will originate this LSA? And flooding scope as well. Till where this LSA floods. Flooding scope. Now tell me, who will originate this type 1 LSA? Every router. Very good. So every router originates, and flooding scope within the area, within the same area. So every router will generate this LSA type 1, and what is the flooding scope? Within the same area. Next LSA type is LSA type 2. What is the name of this LSA? Network LSA. Who will originate this? Very good. Only DR originates. Who is the originator? DR. DR originates this LSA. What is the flooding scope? Again, within the same area. What's the? Okay. So LSA type 3. What is the name of this LSA? Summary LSA. Who will originate this? ABR. Very good. So originator is ABR. Area border router. What is the flooding scope? In between two different areas. LSA type 4. What is the name of this LSA? ASBR summary LSA. So who will originate this? Again, your ABR. So why we use LSA type 4?
Mentioned that there is an ASBR, right?
It tells us the cost between your ABR and the ASBR. Correct? Okay. Next LSA, LSA type 5. What is the name of this LSA?
AS external, right?
External LSA. So it is created by ASBR. So who is the originator? ASBR. What is the flooding scope? In between two different autonomous systems.
Hey Chetan, what is the flooding scope for type 4 LSA?
Type 4 is again in between two different areas.
Two different AS or
areas.
Okay.
So what about LSA type 6? So we don't normally use this LSA. MOSP. Multicast OSP of LSA. So we have one more LSA type, that is LSA type 7. That is NSSA. Why we require this NSSA? LSA? What is the purpose? Summarize means
to accept the
okay, we accept. Good. What?
NSSA area. LSA 5 won't be fled through NSSA area, so we are using LSA type 7, right?
Very good. So now, so NSSA again, who is the originator? ASBR is the originator. Flooding scope in between two different autonomous systems. Now, why we require NSSA LSA? So we have, yes, tell me.
Chetan, just one more thing. What is the opaque LSA? There is one more LSA, right?
That is 6 LSA. We ignore that always. We don't use opaque LSA. It is used to carry your BGP attributes. According to my knowledge, yes. We don't normally use that LSA.
Yeah, actually, I haven't
seen BGP attributes. It is used to carry your BGP attributes like weight, local preference, MED. So that is that opaque LSA is used to carry those attributes. We normally don't use in our regular network. Okay?
Yeah, actually, I haven't seen, but someone asked me.
Yeah.
Okay, thanks, man.
Okay. So we have network types. Sorry, area types we are discussing. So in area types, we have stub. We have totally stub. Finish. 15 more minutes. Finish. So we have NSSA and we have totally NSSA. Okay. So what do you mean by stub? What happens if we configure a stub as a, sorry, if you configure an area as a stub? So it will block your type 4 and type 5 LSA. Type 4 and type 5 LSA. What about totally stop? It will block your type 3, type 4 and type 5 LSA.
Also generate equal to.
Very good. Type 5 LSA. So these both originate a default route for reachability. Originates a default route for reachability. Now, what is the work of NSSA area type? Again, it will block same block type 4 and type 5. It's not bar, it's and. What about total NSSA? Again, it will block same your type 3, 4 and 5. Now, what is the difference between stub and NSSA? So both are doing the same thing. Stub is also blocking type 4 and type 5. Even your NSSA is blocking type 4 and type 5. Whereas totally stub is blocking your type 3, type 4, type 5. Whereas your total NSSA is again blocking same type 3, type 4, type 5. What is the difference? Very good. So on stub and totally stub, there is no ASBR allowed. Means we can't have a ASBR here. No ASBR means you can't configure any external routes inside the stub and totally stub. So if we talk about NSSA and totally NSSA, ASBR is allowed.
Not receive or sends the external.
Which one?
Will not receive the external data from other.
It will receive, but it will convert from type 5 to type 7 because your type 5 is blocked there. Can you see? That way it converts type 5 into type 7 LSA. No? What about the network types?
Just one more.
Tell me, what happened?
Can you just go back?
Can I just?
Go back. I mean, the last, just we wrote that LSA.
Okay, sorry. Okay.
Okay. You said NSSA and totally NSSA, right?
Mm-hmm.
In totally NSA, type 3 LSA will be blocked.
We're talking about total NSA, yes? 3,
Yes,
4
so-
and 5.
Okay, so that is the difference between NSSA and totally NSSA.
Yes, yes.
Can you just tell me a scenario for this totally NSSA? I mean, can you just write down a router or something?
Topology you want?
Yeah, it would be great to make sure, I mean, to understand.
Okay, let us consider we have R1, R2, and R3. So this is in area 0. And this is in area 1.
Okay.
So who is my ABR?
It's
R2
R2.
is my ABR. So now you want to configure total NSSA. So what total NSSA does? It will block your
Type 5, 4.
3, 4, and
5.
And here in NSSA, your ASBR is allowed. Means I can use redistribute command.
Right.
Let us consider I have a loop back here. Okay. Let us consider we have a loop back 4.4.4.4/32. Since it is totally NSSA, it will allow you to use redistribute connected. If other than this totally NSSA, if you use stub or totally stub, it will not allow you to redistribute this. It will prompt you an error. ASBR is not allowed in stub and totally stub. Clear?
Okay, so this 4.4.4 is into a different protocol. Am I right? I mean,
No, just you can use redistribute connected, right?
yeah, redistribute connected.
Why you want again Eigrp again redistribute? You can use redistribute connected. Just go to the
Okay.
router 4, go under what is say your OSPF, just use redistribute connected. So that is not allowed in stub and totally stub. Clear? So please do this lab now. So moving on.
Sure.
So we have network types How many network types we have? Final topic. Okay. So BGP will little bit discuss and then we'll move on to the advanced concepts. So tell me how many network types? We have BMA. We have NBMA. We have point
to multipoint.
Point to multipoint broadcast.
And point to multipoint non-broadcast.
Very good. So now about the neighborship. Now tell me where I need a manual neighbor command and where they will form automatically the neighborship between two routers. Where we need to use neighbor command, where they will dynamically form the neighborship. In which network? Any idea?
In NBMA, I think we need to use the neighbor command. Yeah.
Neighbor command. So here they will dynamically form. Here also dynamic. So what I mean by dynamic is as soon as you go to router, OSPF, process ID, and as soon as you use network, so your network IP, wildcard mask, area, and area ID. So they will automatically form the neighborship. If we talk about NBMA, you need to use a neighbor command. Neighbor, sorry. And neighbor IP. In NBMA, it's not NBBA, it's NBMA. Non-broadcast, broadcast multi-access, non-broadcast multi-access, point to multipoint broadcast, and point to multipoint non-broadcast. So if we talk about timers, that's why we have a neighborship criteria. Timers must match because always OSPF timers depends on the network. So by default it is. So if we talk about hello, please verify this. Hello hold. This is 10, 40 for BMA, 30 and 120 for NBMA. Again for point to point, we have hello as 10 and hold as 40. For both this point to multipoint broadcast and point to multipoint non-broadcast, we have hello as 30 and hold as 120. So these will verify in Dmvpn when we do Dmvpn labs. No? It's okay. So today we'll end up. So before ending up, so everybody please share your mobile number, name, email ID, and course enroll. Paper down, Take on paper, write down your name, mobile number, email ID, and course center.
Chetan, we also need to provide, right? Who are online.
Yes. Okay. So don't put it separate. Please write it everything at once. Then please put it in the chat box. So your name, email ID, mobile number, and course enrolled. Again, name Harshita C. Mobile number separately. I need in a single in this one. What is it? Note. Got right? What you need to write? Name. Just like how Ankur sent, no? Like that, please. Name, mobile number. Got course enrolled and email ID. So everybody has provided their email IDs, mobile number. Yes, online guys. Okay, guys. Thank you so much. Have a nice day. Bye.
Thank you, Chetan. Thank you all.